Today, we will learn more about the relationship between capacitance, charge, and voltage. Let us look at this circuit in which a capacitor is connected to a voltage source such as a battery. As electrons flow from the top plate to the bottom plate of the capacitor begins to store charge. What determines the amount of charge the capacitor can store? Let us use a familiar situation to help us think about this. Here are two containers, A and B. Both have the same height. Container A has a smaller base area than container B. Which container can store more water before reaching its maximum height? If we turn on the taps at the same time, we see that container B is able to store more water than container A before reaching its maximum height. The capacitance of a capacitor is just like the base area of a container. If we connect two capacitors with different capacitances to the same DC voltage, the capacitor with the larger capacitance can store more charge before the voltage across it is equal to the applied voltage and thus stops charging. Here are another two containers, C and D. Both have the same base area. Container D is taller than container C. Which container can store more water before reaching its maximum height? If we turn on the taps at the same time, we see that container D is able to store more water than container C before reaching its maximum height. The voltage applied across a capacitor is just like the height of a container. If we connect two capacitors with the same capacitance to different DC voltages, the capacitor connected to the higher DC voltage can store more charge before the voltage across it is equal to the applied voltage and thus stops charging. To summarize, both the capacitance and the applied voltage affect the amount of charge a capacitor can store. If capacitance is C, applied voltage is V, and amount of charge is Q. The relationship between them can be represented by the equation Q equals CV.